In this video, we want to look at a chi-square goodness of fit test using Minitab. And again, some of my silly examples that we're going to look at here. I got about 3 different that we're going to work through just because of a little bit difference in how Minitab will handle these, right? So when I'm playing board games, I have a favorite set of dice. Okay, my wife always accuses me of getting whatever roll I wanted, and she's accused me of this one particular die that it comes up 6 more times than not. So I rolled the dice 600 times, right? You can read the example. I rolled one of the dice 600 times, and I logged the result of each of the rolls. And these are the results that were shown. 1 came up 92 times, the 2 came up 107 times, and so on. And I would do a chi-square test to determine whether I can conclude that the die are fair or the dice is fair or not fair. So my null hypothesis is going to be that it's a fair die, that there's no disproportionality to the rate at which the numbers come up. In other words, the proportion at which I get a 1, 2, 3, 4, 5, or 6, those are all equal. Those are as they should be. My null hypothesis would be the proportions are not all equal, or that they're not as they should be. So in this chi-squared test, my results are 92, 107, 91, 94, 105, 105, and 111. Now what I can do if I'd like, is put in here the categories 1, 2, 3, 4, 5, 6. Stat tables. In a previous video, we used the chi-square test of association, but this is the chi-square goodness of fit test. It's got 1 variable. Okay, so our observed counts are in C3. The category names, if we would like, this was my reason for putting things into C2. I could put those categories names in there if I would like to. And one nice thing about Minitab is it does say, are your proportions expected to be equal? And in this case, yes, they're expected to be equal. Minitab, unlike the graphing calculator, unlike the TI-84, Minitab will do that calculation for us. So I can just say equal proportions, click OK. And here is our chi-square goodness of fit test. Notice that the proportion is 1 out of 6 for each of those. In other words, out of 600 rolls, each one would have been expected to come up 100 times. Here's the contribution of the chi-squared value, our chi-squared, and our p-value. My p-value is 0.584. Therefore, I would not reject my null hypothesis. I cannot conclude that there's a disparate amount of the number of times the dice is coming up 6. It doesn't come up 6 more often than not. Nice little table here between expected values in yellow and the observed in the blue. And then you will see the contribution to the chi-squared value. In other words, we see that there's more variability from the expected 100 to 6. 6 varies from the 100 more than the 3, the 1, the 2, the 4, and then 5 came up 105 times, and that's the closest to the expected number of 100 times. And that's what that means there, okay? So if I keep going with another example here, same thing with the 2 dice. I'm wondering if the pair of dice is fair. My expected outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The observed counts, okay, were 20, 28, 51, 71, 81, 97, 94, 56, 54, 34, and 14. That's the observed that we came out. Now, if I go back to stat tables, chi-square goodness of fit test, I can't use equal proportions because if I roll 2 dice, remember, I'm more likely to get a 7 than a sum of 7 than I am a sum of 5. So I'm going to use specific proportions. But now I need to tell Minitab in which column I put those specific proportions. Okay. Now, I need to calculate these. 1 out of 36, 2 out of 36, and so on. But if I do 1 out of 36 here, Minitab is going to actually give me a date. Here's, I think, the best way to do it. Actually, let's clear that so it goes back to a general number. 1, 2, 3. These are out of 36. So 1 out of 36, 2 out of 36, 3 out of 36, and so on. 4, 5, 6, 5, 4, 3, 2, 1. Review your probabilities if you need that there. Now, I need to divide everything in C7 by 36. I'm going to go to Calc and use the calculator. And what I'm going to do here in the calculator is I'm going to make C7 now equal to C7 divided by 36. And what this will do is divide all of the values in C7 by 36. So 136, 236, 3 out of 36, 4 out of 36, and so on, and so on. Okay. 6 out of 36 is my 1/6. Right. So that's those probabilities. Okay. Now, stat, tables, chi-square, goodness of fit. My observed counts are now in C6. My category names, let's use that as C5. And then now my specific proportions, those are the values that we now have in C7. Click OK. And then here's what we would have expected for the 600 rolls. Okay. We have a p-value of 0.831, chi-squared value of 5.809. Since my p-value is huge, right, it's not reasonable to conclude that the proportions are different than what we would expect. Okay, so it does appear that we have a fair set of dice. Another example, okay, in a particular city, the Chamber of Commerce has been debating whether it is reasonable to conclude that the post-secondary educational attainment of its residents has changed in the last several years. The table below indicates the post-secondary educational attainment in 2014-2018 based on a sample of 1,000 residents in each year. Tested a 95% confidence level, whether the chamber can conclude that the attainment has changed from 2014 to 2018. Now, in this case, 2014, okay, these are my expected values. I'm wondering, have things changed? I'm going to start by a null hypothesis that nothing has changed, that the results in 2018 that I observe in 2018 will match what I expect if there's been no change based on what I saw in 2014. So if I use 49.8, 8.3, I'll just put these numbers in. Okay. And now 2018 is my observed values. But here's what I want to do. I'm going to make a change to both of these. I observed 100 residents. What Minitab wants is that for the observed value, the 2018 column, that we have the actual number. I'm multiplying each of those by 10 because what we said was, let me try this again, 2018, 478, 73, 269, 180 would be the number of people, excuse me, if I sampled 1,000 residents. So if I sampled 1,000 residents, 47.8% of them said that they have no degree beyond their high school diploma. That would be 47.8%. So that's 478 of the 1,000 residents. Excuse me. Now, in Minitab, what it's looking for here is not an expected value. The TI graphing calculator looks for an expected value. Minitab is going to look for proportion. So Minitab actually wants those percents there written as a decimal. So I'm going to use the tool we did before. I'm going to go to calculator. And I'm going to make my C10 equal C10 divided by 100, changing my percents to a decimal. Okay, we okay? The expected values are as a proportion, as a probability, as a decimal. The observed values, in this case of 2018, those would be the number out of, in this case, the 1,000. So we can stat, tables, chi-square goodness of fit test. My observed counts are 2018. The category names, let's leave that blank because I don't have category names. I could have put them in. I'll go back and put them in a moment. My specific proportions are the 2014, and I click OK. So notice if I don't put in my category names, Minitab will just number them. Okay. If I did put, before I get into all of this, let's go back and put those names in there. This would be none, associate's degree, bachelor's degree, let's do it this way, and graduate / professional degree. Okay, if you want to be lazy like me and not type the whole title. If I go to stat now, back to tables, notice that Minitab saves all of these other settings, but now my category names, I can select C9, which is where I put those values. Click OK, and now notice instead of category 1, 2, 3, 4, none, associate's degree, bachelor's degree, and so on. Notice also the observed is the 2018 numbers, how many out of the 1,000. Testing the proportion, the 0.498, 0.083, 0.264, 0.155. Expected, therefore, out of 1,000 would have been those numbers. Again, the contribution to the chi-square value. So our chi-squared value is 6.135 with a p-value of 0.105. I still cannot reject alpha's greater than 0.05. I cannot reject my null hypothesis. What they would have been, I would have said, is that my null hypothesis would have been that in 2018, the numbers are matching 2014. My alternate hypothesis would be that the 2018 numbers are not matching 2014, that the proportions are not as I expected based on 2014, okay? And we see again, our chart with the yellow is the expected values, the blue are the observed values, and you can see that we've got fewer without any degree at all, fewer associates, but then more bachelors and even more with a graduate professional. It looks like we're moving in that direction of the higher level of degree after, but it's not different enough yet that we can conclude, okay? And then again, the same thing as we saw before, the chart of contribution. In other words, the bachelor's degree has got this smallest variation from what we expect, and then the non-associated and graduate degrees. But our p-value is 0.105. So there's how I do a chi-square goodness of fit test using Minitab with a couple of different scenarios and examples that do show up.